In 1665, Sir Isaac Newton forever altered our perception of physics. Welcome to Brewtech. Newton's three laws of motion not only revolutionized our understanding of the world, but also paved the way for the development of classical mechanics. These laws explain everything from the simple act of throwing a ball to the complex movements of celestial bodies. So let's strap in and prepare to explore these fundamental laws and their profound influence on the world we live in. Newton's first law, often referred to as the law of inertia, is quite straightforward. This law tells us that an object will keep doing what it's doing until some force causes it to do otherwise. Imagine you're on a frictionless ice rink. If you push off from the side, you'll glide across the ice indefinitely without slowing or stopping unless something like a wall or another skater interferes. The same is true for an object at rest. It will stay put until a force compels it to move. This might be gravity pulling an apple from a tree or a gust of wind blowing a hat off your head. So in essence, an object in motion stays in motion, and an object at rest stays at rest unless something else steps in. Moving on to Newton's second law, which introduces us to the relationship between force, mass, and acceleration. This law is often expressed as F equals ma. Here, F represents the force applied to an object, M stands for mass, and A represents the acceleration. Essentially, what this law tells us is that the acceleration of an object is directly proportional to the force applied and inversely proportional to its mass. This means that if you apply more force, the object accelerates more. However, if the object is heavier, it will accelerate less. So whether you're pushing a shopping cart or launching a spacecraft, this principle holds true. In other words, the more force you apply to an object, the faster it accelerates, but the heavier the object, the slower it accelerates. Finally, we arrive at Newton's third law, the law of action and reaction. This law may seem intuitive, but its implications are profound. It declares that for every action, there is an equal and opposite reaction. Picture this. When you jump off a boat, it moves backward. Your force on the boat propels you forward, while the boat experiences an equal force in the opposite direction, causing it to move backward. The same principle applies when a rocket launches into space. The force exerted by the rocket's engines propels it upwards while pushing an equal amount of force downwards. To put it simply, any force exerted on a body will produce an equal force in the opposite direction. These laws may seem abstract, but they have real-world implications. They guide everything from the motion of planets to the design of rockets and cars. Newton's laws of motion are fundamental principles governing the motion of objects in the universe. They continue to shape our understanding of the physical world. Thanks for joining us on Brewtech. Comment what you would like to see next.